Assalamualaikum and good day everyone. We are from Group 4, so we are presenting ethical issues in engineering practice. What is ethics in engineering? Ethics in engineering refer to the set of moral principles and professional standards that engineers must follow while performing their ethics in engineering. First is environmental ethics, where engineers must protect the environment, ensure sustainable development. Next, computer ethics. Engineers must use computers responsibly, preventing misuse such as hacking. Next, research ethics. Engineers must uphold honesty in research design. Another relevant ethical theories include deontology, focus on the engineer's duty to do what is morally right regardless of the consequences, and the utilitarianism, focus on actions that provide the greatest benefits to the majority. In Malaysia, the main act and regulation related to ethical issues in engineering practice are: first, Registration of Engineers Act 1967, Act 138, amended 2015, governs the practice of engineers in Malaysia, requires engineers to register and comply with professional standards, including ethical behaviour, gives authority to the Board of Engineers Malaysia (BEM) to regulate and enforce ethical conducts among engineers. Second, Board of Engineers Malaysia (BEM) Code of Professional Conduct, a set of ethical standards that engineers must adhere to, covers responsibilities to the public, employers, clients, and the profession itself, focus on honesty, impartiality, fairness, competence, and public. So, who is responsible for the enforcement? First, the engineer themselves must uphold ethical standards individually. Next, professional bodies such as Board of Engineers Malaysia (BEM) and Institute of Electrical and Electronics Engineers (IEE).
Next, I will continue for fundamental issue at hand in engineering ethics. The core issues is the professional responsibility engineers carry towards society and the conflicts arising from this duty. Engineers design and manage systems impacting safety, health, and the environment, often facing ethical choices when decisions meet competing interests. This leads to three key aspects. First, balancing competing demands, where engineers must constantly navigate complex technical needs, project budgets, and deadlines while upholding their ethical obligations. Second, the potential for harm, which failures due to errors, dishonesty, or incompetence can cause significant negative consequences like injury, environmental damage, and erode public trust. Finally, maintaining professional integrity is crucial. This means ensuring engineers are honest, skilled, avoid conflict of interest, are truthful, and work within their expertise. Next, we move to the benefits and impacts. Under benefits for enforcement, ethical practice is vital to build trust with clients, government, and the public, assuring them that projects consider their best interests. It also upholds professional integrity, maintaining the respect and credibility of the entire engineering profession. Looking at the impacts on society and employers, ethical actions lead to a safer society with more responsible and sustainable designs. For engineers and their companies, ethical conduct drive long-term success, build a strong reputation, and avoids costly legal issues or loss of public confidence. Next, let's cover some other important related details. Firstly, we have formal codes of ethics. Many professional organizations provide these guidelines to direct engineers on expected behaviors like honesty and fairness. Secondly, engineers must be alert about conflict of interest, where personal interests could potentially affect professional judgment, and transparency and honesty are key here. Lastly, the globalization impact presents unique challenges. With international projects, engineers encounter varying cultural and legal standards, requiring careful navigation while upholding core ethical values. These factors add important context to ethical engineering practice.
So, the first case study regarding the ethical issue in engineering practice is He Jiankui and the CRSPR babies that he modified. So in 2018, a Chinese scientist named He Jiankui shocked the global scientific community by announcing that he able to modify the embryos of twin girls, Lulu and Nana, by using the gene editing technology CRISPR, making them resistant to HIV. So this was the first known instance of genetically edited humans being born. There are several problems regarding the case study that we have studied. One of them being lack of transparency, where He Jiankui conducted the project secretly without having an appropriate peer review, public discussion, and also governmental approval. Next one being the violation of consent, where the parents were not fully informed regarding the risk and also the technical issue regarding the modification of their babies. Next one being the breach of professional integrity, where the scientist himself see this project as him being pursuing his own fame and also his personal ambition instead of helping others. And then lastly is the premature application of the new technology. From what we have studied, that the gene editing technology is an experimental tool and newly developed with having a risk of mutations. So using it is a quite reckless and also an unethical behavior from the scientist himself. So from this case, utilitarian principle might be justified because of the positive outcomes outweigh the risk, and also by using the scientific knowledge by the scientists could help more people in the future. However, we cannot use this principle in this case because actual risks to the twins were unknown. We don't know whether or not the babies suffer more instead of benefit more. And then the procedure was very unnecessary because we already have HIV prevention to begin with. And then the twins themselves had no say in the risk that they were exposed to. Obviously, He Jiankui has violated the duty ethics instead, where he does not protect the fundamental right regardless of the outcomes. And the babies were edited without their consent. He does not follow the moral laws, which is mandatory, and also misled the consent document, which I already previously explained, where he violated the consent of the parents of the babies. Some of the pathological science can be applied in this case, which are fantastic theories, where the idea that a simple genetic edit could create immune to any kind of diseases, and then ad hoc excuses, where the scientists, rather than accepting legitimate scientific and ethical challenges, he keep justifying that his action is not unethical. Rise and fall is where the case start off with a massive excitement, but later on becomes decline due to the fact that the action is becoming clear that it is illegal and also has several flaws. So the lesson that we have learned from this case are researchers must maintain skepticism even when faced with promising new technologies. Research should be peer-reviewed and open to scrutiny, not by secrecy. Lastly, is research should be motivated by genuine scientific curiosity and the desire to improve humanity, not by personal ambition.
Hello everyone, my name is MITHUN SUDESH and I'll talk about the case study 2, which is the explosion of Challenger space shuttle. An incident that took place on January 28, 1986, as the space shuttle Challenger exploded just over 1 minute after liftoff, killing all 7 astronauts on board. The tragic incident was caused by the solid rocket booster's O-ring seals that failed to seal properly, thus permitting the hot combustion gases to leak out. These gases burned through the external tank, leading to the tragic explosion. The subsequent investigation showed that the O-ring's failure was due to various reasons, including bad design of the booster, poor testing of O-ring materials, and joints under cold conditions. This is a catastrophic breakdown in communication within NASA's management. The relations to the theme of ethical issue and engineering practices are neglect of public safety, where engineers, including Roger Boyce-Joly, warned that the O-rings could fail in cold weather. Despite this, NASA launched the shuttle, prioritizing schedule over safety, which is an ethical breach that put public lives at risk. Next is the suppression of professional opinion. Boyce-Joly, who is an engineer, and his team advised delaying the launch for safety reasons, but management ignored them due to the outside pressures. This highlights the ethical dilemma engineers face between standing by safety concern or yielding to organizational demands. Next is communication breakdown. A major factor in the disaster was the failure to properly communicate engineers' technical concern up to the management chains. Their safety warnings were not clearly presented or acted upon, leaving an ethical issue in ensuring that critical risk information is heard and considered in decision making. Next is whistleblower retaliation. Post-disaster, Boyce-Joly faced professional ostracism for his attempts to prevent the launch and for speaking out afterward. This retaliation against whistleblowing raises ethical concerns about protecting individuals who act to uphold safety and integrity within engineering practices. Now, what are the roots of the problem? Firstly, we have the design flaw in the O-rings. The solid rocket boosters O-rings seals were not reliable at low temperature, but were never adequately redesigned or tested for such conditions. Next is inadequate testing. There was insufficient cold weather testing of the O-ring materials and booster joints, despite known concerns. Next is suppressed engineering inputs. Engineers like Boyce-Joly warned against the launch, but their concerns were ignored or silenced under pressure of the management. The lessons that can be learned here are: we should integrate safety from the start by applying safe design principles early in development and not as an afterthought. This ensures all components are analyzed for risk and tested thoroughly. Next is opinions of engineers must be heard. Organization must create a culture where engineers feel empowered to express concerns without fear of dismissal or punishment. Next, we should have effective communication, which is critical. Technical concerns must be clearly and directly communicated to decision makers. Complex risks should not be watered down or filtered through multiple layers of management. To conclude this case study and our advices, the Challenger disaster was more than just a technical malfunction. It was a clear example of ethical failure in engineering. Despite known safety risks, warnings from engineers were ignored due to organizational pressure and a prioritization of schedules over human life. This tragedy teaches us that ethical decision-making, transparent communication, and the courage to speak up are fundamental responsibilities in engineering practices. As a group, we conclude that engineers must put safety first even when under pressure. Organizations must create environments where technical concerns are heard and valued. And lastly, ethical responsibilities are as important as technical skills in any engineering role. Our advice are, as future engineers, never underestimate your voice. If something doesn't feel right, technically or ethically, you should learn to speak up. Stay informed, stay honest, and always remember that your decisions can impact the life of others. Your integrity and courage might one day prevent a tragedy. So, let the Challenger disaster be a lasting reminder of why ethics in engineering truly matters. Thank you, and that's all from us.